All right, and here we are at the bottom of page 1. So 2.4, page 1c. We just did each example in its own video here. So you can pick and choose what you need to look at. Again, we're using our same steps we did in 2.1, 2.2, and 2.3 to now solve a formula. Oh, I forgot to mention, I think you can still see this on screen here, but the question would be, what does this formula represent? And just like number 10 represented a linear equation, this one, number 26, also represents a linear equation, but it's known as the standard form. I call it the formal version. While the y equals mx plus b from our first example at the top of the page is more like our friend, it's actually what I call an instant graphing. We'll learn the official title of it as the slope-intercept form of the linear equation. What we're looking at down here on 26 was linear equation standard form. So now let's look at number 18, and remember what the directions are. They were to solve this equation for the specified variable. So in this case, we're going to solve for d. So let's highlight d here in our equation. So we want to rearrange. Our goal here is to rearrange so we get d equals, and this is the rest of the equation. Okay. Right now there's a bunch of things happening to d. We're going to strip all that away, move it to the other side so that we end up with d equals something. Okay? So let's do what we've always been doing. We check to see if there's any parentheses that need to be removed. We look on either side of the equal sign to see if there's any like terms that need to be combined. These two steps together are what's known as simplifying the equation. We make sure that the variable we're interested in this case d, has picked one side to be on, and if not, we use opposite operations to get it there. But in this case, what you'll find is true for a lot of the problems that you do in this section, it's all taken care of. There's no parentheses, there's no like terms on either side of the equal sign, there's nothing that you can combine on either side to make it simpler, and d is already just on one side, in this case the right side of the equal sign. So the next thing we do is we ask ourselves, what's happening to d? We're kind of used to, well, what's happening to x? Well, there's more than one variable here. There's d and there's p. So they told us to solve this for d, so that's why we're focused on what's happening to d. So there's a lot of things going on here. In this case, it's our very first three-step equation. It's not the only way to solve this. If you can look at this and know exactly how to start and you're confident and you get the right answer, then your method is working great for you. What I'm about to do, like we've done in the entire chapter 2, is for those of us who look at this and go, I'm not really exactly sure what I need to move around first, or whether I need to multiply or divide or add or subtract. This will help you figure that out with no doubts left. Okay? Ask yourself, what's happening to d? Meaning, if we were to replace d with a number, what would order of operations tell you you'd have to do first? The 5, the 11, or the 15? The 5, because it's inside a grouping symbol. The fraction acts as a grouping symbol, and it's multiplication. So you'd multiply by 5. What would you do next to d? Well, then you've got whatever this answer is, division and addition. Division comes first, so you would divide by 11. After that's done, so now imagine you put a number in, multiply by 5, get an answer. Divide by 11, get an answer. What's the last thing left to happen to this d that we put in? Add 15. Okay. Or if you were to put that in more of a timeline sort of thing, kind of looking left to right here across the page, we would say you'd start with d, you'd multiply it by 5, then you'd divide by 11, and then you'd add 15. That's just kind of a visual notation of this same list. Okay, it's not necessarily in terms of order of operations always correct, but in terms of just looking at this. So that's why I write that arrow to remind us this is just a timeline. This is just a way to tell us what happened in order as we read left to right. So now to solve d, to get d by itself, which is our goal here, we undo everything that's happening to d. So we reverse our order. We go up the list, or on the timeline, we go from right to left. If we go up the list, instead of 1, 2, 3, we would go 3, 2, 1. So 3 is our new first step. 2 still remains in the middle, but our original first step is now our third or our last step. And every operation becomes its opposite. Instead of adding, we're going to subtract. Instead of dividing, we're going to multiply. Instead of multiplying, we're going to divide. You'll get that same list. First step, subtract 15. Second step, multiply by 11. Third step, divide by 5. You'll get this same prescription by going right to left across your visual timeline and do everything opposite. Instead of plus 15, minus 15. Then instead of divide by 11, times 11. Then instead of times by 5, divide by 5. Okay? So it's just a prescription here as you read right to left. So let's apply that now. Our first step, either using this list or using the timeline, the first thing we're supposed to do is to subtract both sides by 15. Subtract 15 from both sides. And I forgot to rewrite my equation, so I'm going to go ahead and do the subtract 15, but I'm going to shift everything over. So on the left side, this is what feels a little funky about this section that we're in until you get used to it. We normally would expect the p minus 15 to be a single number answer here. As we start to move things away from d, we just keep a number running total over here. We don't know p, so it's going to stay p minus 15 on the left. But the 15s cancel. That's the whole point. That's why we set it up that way. That's what our prescription is going to do, is slowly pull things away from d. So the 15s cancel, 15 minus 15, and we're left with the 5d over 11. Now we look at our prescription. We've done step 1, which is to subtract 15. As you go right to left, we subtracted 15. The next piece says times 11, so does step 2 here, multiply by 11. That means both sides, that's critical. Whatever you do to one side, you have to do to the other, okay? So I'm going to multiply this entire left side by 11, and I'm going to multiply this entire right side by 11, which is like 11 over 1. The 11s cancel, that was the whole point. And over here, you can just leave it as 11 times p minus 15, or if you choose to, if you have that instinct to distribute, feel free. 11p minus 11 times 15 is going to be 165. Do you know the multiply by 11 trick? You take the 1 and the 5, and then in the middle you add them together, 6. So 11 times anything, that's the trick, how you get that answer really quickly. And then over here, it's equal to 5d because the 11's cancel, okay? Which we expected to happen. That's the whole point of solving here, is you get rid of what's happening to the variable. So we did step 2. Now step 3 says we're going to divide by 5 both sides. So I divide by 5. I divide the entire left side by 5, okay? And my d is equal to 11p minus 165 over 5. And you can use the back of the book. You could plug this back in. I'm out of paper space here, but if you were to plug this back in for d, the 5 multiplied would cancel the 5 on the bottom here. Then you divide by 11, and it goes into both pieces by 11. Then you'd be left with the p minus 15. You'd add the 15, you'd just get p. You'd have a true statement. So it does check, but again, feel free to use the back of the book because that's why I assigned the odds. And actually, I have to tell you, I was not familiar with this formula. And remember, the second question is, do you recognize the formula? If so, what does it describe? And in this case, this formula, I had to look this one up. It was kind of a fun internet search. So I typed in p equals 15 plus 5d. I think I actually typed the words divided by 11. And a little bit of searching found that p represents the pressure. Sorry, my pen quit working there. The pressure of seawater at a depth of d feet. So, interesting little formula there. P represents the pressure of seawater at a depth of d feet. So when we rearranged it, we now have a formula that finds the depth you're at if you know the pressure of the seawater. So interesting little things we learn along the way here. Okay, that takes us through our first page. We'll see you at page 2 for some more practice.